initial script of a pure PLC mob assembly machine by teaching. 3. Last time we talking about the P4 备料剪枝 CC file running. At the end of P4 will accurate the P1 CC file and P1 CC and P5 CC as well. At the same time, P4 CC running, the P7 CC file is running as well. At the end of P7 CC will activate the P8 套关补料豆的 CC file and P9 套关补料 CC file. Right now, in this stage, the P8 and the P5 CC as well as P1 CC and P5 CC 4 CC file is running. We're talking about the P8 套管补料 CC file first. The number 8 control system. The script list down here, but we already output the Excel file. Let's see the Excel file as ASCII code, better for looking. P8 套管补料 CC file combined with the cartoon chart is better for looking. The P8 is the 套管, the outfittings drop from the supplier. Here with the P7, P14, 17 and the P18. P18 to cut the material, P17 to let go one outfittings down to this position. And then Y17 will on to hide the positions to prevent the dropping of the outfittings and retract Y18 back to home position. Finish a cycle. Let's see the procedure of the script. The same, the S8 activated the first instructions. Use K21 input 8 to cross the input procedure, and then use K20 activate Y18. Then the plate will insert into the wrong weight to prevent the dropping and to cut the material to let single one in between Y17 and the Y18. After cutting the material, K21 Y17 will retract the plate back, let the one drop down the positions, waiting for the assemble as S7 activated. This is PLC control K20, Y18, K21, Y17. The simulation, this one is object 1, this is object 2. This one will thrust in. So K26, object 1. Okay, this is object 1. Object 1 thrust in. According to the picture here, the P8 CC is doing the right sides. So this thrust in, this is minus X direction, 30 millimeters. So the object 1 moving X minus 30 millimeters by K26. So this one thrust in. And then this object 2 retract back, use K26, object 2 back to 0, positions to let go the 1 drop in positions for assembly. And then there's no input sensors in here and in here. So after that, immediately actuate Y17 by K20 Y17. As Y17 actuated, the plate will insert to block the dropping of the outfitting. And then K21 Y18, the Y18 will retract back to let the outfitter drop 1 in between Y17 and the Y18, since Y17 is tracked out to prevent the dropping of the outfitting. This is for PLC control. The actual control, the 3D simulation, use K26 object 2 moving along minus X directions, 30 millimeters. So this will extend 30 millimeters along minus X direction, and the object 1 retract back to 0, positions. So you can see K26 object 1 0, as this retract back the sensor X28, the input 28 become 1, the moving will stop, and this extension to the limit, the input 27 will report 1, the moving will stop. So 32, 27 input, waiting for 27 input become 1, and waiting for 28, the input become 1, and then continue the next step. Okay, this is S8 P8 CC files working. Let's see the simulation. This is S8. This is number 8 control systems. You can see the script just the same as the Excel file. Okay, let's run it. But as run it, the last one is the separating piston on. We have to, if we don't want to see this play at home positions, the better to wait for the few minutes for observation. So we use delay to wait 5 seconds. So you can see at the last this insert in positions and 5 seconds it will return back here. So let's talk the actions first. As running the script of P8 CC5, the cut with piston on, this one will go insert and this one will return back. In no time, this one will insert, will return back. This one will insert and waiting for 5 seconds. This will back home positions as well. Okay, let's run. 5 seconds, return back. Okay, good. Let's see it again. This in, this return back. 5 seconds, this return back. This is what P8 CC file does. Okay, let's continue to see the P9 CC file working. Now then, let's see the P8 套管谱料 CC file together with the cartoon chart to see here. Let's say CAN21, the input 9 crossed, and K20 open Y23 to cut the material, and K21 Y22 to cross the Y22. So the Y22 object will return back. This is object number 2, will return back to home positions. The PLC control K20, 23, K21, 22. For the 3D simulations, for this one, this object 1, use K26, object 1 moving minus 30 millimeters. Let's see. This direction is y is x minus direction. So this one moving 30 has to fill minus 30 in x blank space. So you can see K26 x minus 30 for object 1, while object 2 K26 retract back to home positions 0, 0, 0. As this one retract back, no sense, no sensor. This one is turned to this position, no sensor. So there is not any K32 waiting for the input sensor become 1. Immediately retract back Y23. So before retract back Y23, we have to insert Y22 first. So the next line is K20 Y22. Let the Y22, the leaving cylinder, move on to block the falling of the out fittings from the supplying pipe. And K21 Y23, this one will retract back. Then to let one out fittings fill in this space between Y22 and Y23. The actual movements is the second object. It is tend face the minus x directions 30 millimeters thrust in, and the object 1 retract back. Use K26 object 1 back to 0, 0, 0 positions, and then waiting this one in, waiting for input 38 become 1. This retract back, waiting for input 36 become 1. So there are two instruction lights. K32 input is 36, and another is K32. The input value is 35. So this is the script of P9 套管补料细细 file. Let's see the simulations for number 9 control system. You can see the programs just the same as the Excel file. Okay, we use retract to remove this light, and for better looking, this one at the last still inside to block the falling of all the fitting. We better to set delay for 5 seconds. After 5 seconds, this plate will back to original position. That means outside the blockage position. Okay, next one. You will see this one in, immediately out. Before out, this one has to be in first, and waiting for 5 seconds, this one will be out as well. Okay, wrong. In 5 seconds, retract back. Okay, let's see again. In retract back. 5 seconds, retract back. Okay, this is the way P9 CC file does. Okay, then we are commence to do the P5, the inner tapping assembly CC file. Better to turn the mechanism 180 degrees to see in better positions. Okay, the other side's blockaged. You can see it's blockaged. So we just adjust to see a better position. Okay, this way is better. Here already fixed the channels, not like the P7 with the up and the down holders to create a channel. Before executing P5 CC file, here is one, the other one in positions what's the one? Its inner tappings, fittings already in position, and then the pipe, aluminum pipe already on the teeth. Okay, for P5, better to change to number 5 control system. This is the script. Then for better looking, we open the P5, the inner tapping assembly CC file, just this one, and together with the cartoon chart S5 to activate the P5 inner tapping assembly CC file. In this script, the Y6 will on, the Y9 will on to push the inner piece from both sides, thrust in inside the tube, the aluminum tube. Okay, the program you can see the K21, the input 5 crossed, and Y6 use K20 to activate it, and Y9 use K20 to activate the Y9. This is for controlling the PLC. For the 3D simulations, this is object 1. Will let the piece moving down. Minus direction is moving down to minus Y 100 millimeters distance by using K26 Y minus 100. The object 1 works, and this one moving up 100 millimeters up along Y direction by using K26 object 2 positive direction 100 millimeters in Y direction. This in waiting for input 8 and input 12 become 1. So by using K32 input 8, another line is K32 input 12. After assembly, we have to retract Y6 and Y9 by using K21 Y6 off and K21 the Y9 off shut. This is for PLC. For simulations is K26 the object 1 back to 00 positions, and for the second objects K26 the second objects back to 00 positions, and then waiting for the input 7 become 1 and the input 11 become 1 by using K32 input 7 K32 input 11. After that, we have to activate the S2 as well as S3 by using K20 input 2 K20 input 3 to feeding 1 in internal tapping parts to this space, and this one the same. Activate the P3 CC file to drop 1 internal tapping piece, waiting for next assembly. This is what the P5 CC file does. Okay, let's see the simulation. The simulations, the program you can see already. We use reset to remove the lights in here, and there, wherever there is data in the data buffer, we can run. We have to see this is number 5 control system only in here, so the piece will be pushed from both sides to insert into the aluminium pipe. Okay, let's run. Have you seen the push items showing on these positions and retrieve back? Okay, let's see again. See it again. See it again. Push and back. Push and back for the internal tabbing parts assembly with the aluminium pipe. Okay, this is P5 CC file does, and then we'll see the S1 be touched. This one will lift a distance and then retrieve back to see the P1's CC file. Okay, then together to see this one running together with a carton chart. The same, we'll see the CSV file in more detail. P1. As P1 CC file executed the first instructions, use K21 to close the input 1. And then the Y1 will be activated. The K20, the Y1 activated. The 3D simulations is to moving along Z directions 40 millimeters. So use K26 object 1 moving up Z direction 40 millimeters. So this one will moving up. And then waiting for the input 2 become 1 by using K32. Input 2 sensor become 1. And then after input sensor 2 become 1, then retract the Y1 back by using K21 Y1. The 3D simulation is K26. Object 1 back. As you go back, it will touch input sensor S1. So we need to wait the input 1 at the real. Okay, then we save it again. And leave. And then let's see the simulation. The number control is 1. At the end, we have to add a waiting by using add one last 32, waiting for what? For the sensor is S1, become 1. So this should be 1. So you can see K32 input 1. So we have to save it P1 除料减值 CC file by using save CC P1 除料减值 Okay, that's it. And then let's see the simulation. Run. You see, it's moving 40 millimeters up and drop immediately. Okay, P5 cc, P1 cc already done. At the end of P5 cc, we'll move, actuate the P2 at the right size as to prepare one space, one freed internal tapping parts in positions waiting for the internal tapping parts assembly, and S3 will prepare one at the right size. Let's continue to see the P2. So let's change the control station to number 2. The same. Let's see the P2 CC file. P2 内压补料 CC. P2 CC file. The same. P2 内压补料. The first instructions use K21 to cross the input procedure number 2, become 0. And together with the cotton charts, the S2 actuated. The Y4 on first by using K20 Y4. What the meaning of Y4? The Y4 is cut material. The dropping along the pipe, the slope is 45 degrees, almost. So at the top, using Y4 actuated to cut, to prevent the drop, actually to cut, to late single one left at between Y4 and Y5. At the moment of Y4 thrust in, the Y5 is thrust in as well. So in between there is one. Let's see the join in here at the right side. Just here. This one in to prevent the dropping. And these parts assembly already. So there's nothing waiting here. This one in to prevent the dropping internal parts. Let's try to fit in one at the space. The cutting cylinder will thrust in first, and to cut, to let single one in between display and the display, and then this one retract back, this one remain on the way to prevent dropping. So this one will drop in position to fit in the blank space. And in those moments, this separating cylinder will actuate the thrust in, and the cutting plate will retract back to let the top internal parts drop one in this space. Okay, let's continue to see the P2. So K20 P4, the cutting plate thrust in, and K21 Y5 off. This one leaving to drop the piece in between to the positions in here. And for the actual movements is K26, the object number 1. Object number 1 is this one. Move along X distance 15 millimeters and Z directions 15 millimeters, because this slope is 45 degrees slope. And for Y5, this one separating, just retract back, use K26, let the object 2 back to 0, 0 positions. And there's no sensor, so there isn't any K2032. Immediately the Y5, the leaving cylinders will be actuated by K20 Y5. This one will thrust in, and the cutting plate will retract back by using K21 Y4. The actual simulations for Y5, this one is by using K26, the object number 2. Object number 2 moving the X direction 15 millimeters, the Z directions up 15 millimeters, thrust in. This one thrust in, and Y4 retract back to home positions by using K26, object 1 back to 0, 0, 0 positions. And then waiting for, this is retract back, waiting for input 5 become 1. This thrust in, waiting for the input sensor 6 become 1. So K32 input 5, K32 input 6 written at here. Okay, this is the P2 CC file. Let's see the simulation. P2 already the programs in here. You can see K32 5, K32 6. Okay, let's run it. Before running this program, it's better to add 5 seconds at the real. K22 5 seconds. At the last, this one will be in, waiting for 5 seconds at the last to retract back in position. Okay, let's go. Now this one will in and out. Before this one move out, this one has to be in. Okay, let's go. 5 seconds, this one will be out. Okay, good. Again, in. Okay, good. Then we'll see P3 in that size, the internal parts supply. Let's turn to the other view for better looking. Okay, just these two. It's very close, so we have to see it more close. This one for cut material, this one for leaving the material. The same. Let's see the P3 内牙补料 CC file. The same, the first instructions use K21, the input 3, that's off. And Y7 will in to cut material to leave 1 parts in between Y7 and the Y8. And the K21, Y8, this one off, return back to lay the single one drop in the positions waiting for the assembly. The actual movements is object 1 moving along x positive direction 30 millimeters and up z direction 30 millimeters. This one 45 degrees thrust in, and this one retract back to home positions. The K26, the object 2, back to 00 positions. And then there's no sensor. Here's no sensor, so there isn't any K32 waiting for input become 1. Then this one will thrust in. After thrust in, this one retract back. So Y8 thrust in by using K20. Y8 up, and this is Y7 retract back by using K21. Y7. The simulation is this is object 1, K26, object 1, 000, and the object 2 thrust in, the K26, object 2 thrust in, the x distance move along x positive directions 30 millimeters, the z direction moving up 30 millimeters. Because this is 45 degrees, the z distance and the x distance the same. So this thrust in, this is retract back. So in between, feeding 1 internal piece. As this move in has to wait the input 10, this one retract back has to wait for the input 9 become 1. So we can see K32 input 9, K32 input 10. That's the P3's CC file. Okay, let's see the simulation in here. Better to put a waiting 5 seconds at the rear before the button 1 retract back. You can leave in positions 5 seconds. Okay, let's run it. Retract to remove this light first. Okay, let's set it. Okay, wrong control. It should be number 3. Okay, retry. So we cannot see correct showing. It should be number 3 control system. And the last tail, still no waiting for 5 seconds. We have to use set delete 5 seconds. Then the number 3 control system, K22, 5 seconds waiting. Okay, let's go. Run it. This one in. Before this one retrieve back, the separating cylinder will in first. And waiting for 5 seconds, these leaving cylinders will retrieve back to home position. Okay, reset. Running again. The PLC works very fast, so we have to see quick. That's the way P3 CC file does. Okay, ending for the whole visual script editing by teaching.
起。